Identify the test intervals for the quadratic inequality. We have x squared plus 2x, which is less than 3. So the first thing we're going to do is we're going to subtract 3 to the left side. So we get x squared plus 2x minus 3, which is less than 0. And so now what we want to do is we're going to take this quadratic and we want to factor it to determine what are the critical points. So we're going to set it equal to 0. So when we factor this quadratic, we have negative 3 and we have a positive 2. So what two numbers can we multiply to get negative 3? Then when we add them together, we get positive 2. We get negative 1 and then positive 3. So when we factor this, we get x minus 1 times x plus 3, which is equal to 0. And so therefore we have x minus 1, which is equal to 0, or x plus 3, which is equal to 0. So therefore x is going to equal positive 1, or x is going to equal negative 3. So therefore these represent your critical points. Okay, now, but what we want to do is we want to figure out what are the testing intervals for the quadratic inequality. So in order to figure that out, if we have a number line, okay, and we have our 0, we need to plot the point negative 3, or at least identify it on the graph, and then the value of 1. So what happens here is that we have these regions that are divided through these critical points. So we have region number 1, we have region number 2, and then we have region number 3. So in region number 1, we're going from negative infinity to negative 3. Now because this is a less than, we're not going to use a bracket for any of the critical points because it's less than, which you're not going to include it. So the first interval is going from negative infinity to negative 3. For region 2, we're going to go from negative 3 to 1. So therefore it's going to go from negative 3 to 1. And then in region 3, we're going to go to 1 to positive infinity. So therefore this is 1 to positive infinity. So therefore we can say that the intervals are negative infinity to negative 3, negative 3 to 1, and 1 to infinity.